Can I introduce you later? You have. Yeah, we as a talk a while back. But you were not. I didn't even try to.
Only need to mute everything.
Yeah, okay. I muted. Just to check again now, just to make sure.
Just now I muted for you.
Oh, you did? Okay.
Yeah.
Okay. Never mind.
You no.
You don't play around with it. Yeah. Sekali. Anyway, what is it?
You need to share in here.
Yeah, what? Share screen.
Yeah. Don't. Pause it. When you share screen here, you only show up in Zoom.
You sharing the wrong. Oh, correct. Yeah.
You know, you won't show up in Zoom.
Yeah.
Oh no, this is not high school.
Okay.
Yeah, for undergraduate. Yeah. Oh, sorry. Oh no, from the US. Big deal. Yeah, I think US has. So that one also affected. Mortgage, current application. This is kind of more just coming. That's actually more for ourselves to what have we done? Yeah, study break or take stop. Yeah. I don't know. Okay. Where have you been in my way? Did that take on you?
Okay, I just press. But later the speaker need to pick. Yeah. Maybe we wait 2 minutes more. Yeah. Hey. You want to test? Oh, just. It's not working. Okay, and then the speaker will have to press that. Okay. All right. I think our key people are here. Collaborator Jeremy is here. We've been waiting for you. Okay, never mind. Good morning, everyone. My name is Si Kyung. If you do not know me, I'm your host today of this special occasion. This is our very, very first IDS. Yes, what do you want? IDS Open House Day. Yeah. So IDS or Institute of Data Science. Yes. How to move forward? Okay, so IDS was formed about 7 years ago, actually this month. In next week's time, we will be celebrating our 7th birthday. by the university, and we were given a very grand vision to be globally admired, okay, for groundbreaking research, okay. But basically the aim is to enable efficient discovery. So speed, efficiency is something that we're looking for. Computational technique, very important. Or reliable, meaningful knowledge from data, right? So those of you who work on ChatGPT, now you know reliable is very important, and meaningful knowledge. So this one will need a lot from our other disciplinary who perform data science like business school, engineering and all this to tell us what is really meaningful, as well as also we work with School of Public Health. For informed decision making by individuals, business and government on real life. Real life is another thing that we focus on a lot, challenging problems. So you can see it's a tall order, but the university gave us a lot of money actually. I don't tell you how much, but they managed to get Microsoft CEO to come here and press the button, and they are able to hire me from A-Star, which I used up a lot of funding. So, but I did better. Okay, so that's our vision. So I thought I'll share with you today. So, but 7 years has passed. We have endured the pandemic. We now are looking at the dawn of general artificial intelligence. So we have been working actually very hard. So the areas that we are focusing on, the data science capabilities, in terms of application, we look at healthcare. I was telling Raymond just now that we are all getting old, but we have a responsibility of keeping ourselves fit, just in case the AI doesn't work. But we also want to make sure, in case we can't keep ourselves fit, we want AI or data science to help us maintain our health. So healthcare is something very important, mostly because all of us will become old later, and then we want technology to be there to help us. So today, our talk will be also focused a lot on that. The other is want our city to be smart. So smart cities, it's very important. I think we are all living in a smart city now. Each of us carry a mobile phone that's like supercomputer during my time. So, and it's all connected and everything. And you know, we experience this smart city during our pandemic. If not for all this technology, I think we won't survive the pandemic so well. Okay, so it's very important. Now, in terms of the so-called area, we are now, I mean, there are a lot of other things, like deep learning and all this stuff that we look at. But we focus on two things now. You should see some showcase today. One is federated learning. It's about how, since the Institute of Data Science, sharing of data is very important. Actually, one of my previous life, I looked a lot at sharing of data. I find it's very hard to share data. So by that federated learning techniques, and then we're trying to see how we can share for a purpose. It's not to share data for the sake of sharing data, but it's sharing for learning. So that changed the perspective a little bit. Okay. Today we're not talking about federated learning, but maybe you can come back again next time. We'll have a session on that. But the other one that all of you know now is natural language processing. So it's a very exciting time now. We'll hear two talks, invited talks later, right? And then again, we also look at different types of data. One data, we have a lot of text, and very interesting data will be the social media. So we focus on these areas. Okay, so these are the key focus. We cannot do everything, but so just to share with you, these are the areas that we look at. Then remember, our vision is we need to have real world impact. So our belief is that we want to look at the real data. Okay. It's no point working on, okay, some of you write papers, you benchmark, you test on benchmark data, you call that real world data, you squeeze a little bit more and say, that would be all the state of the art. But when you move to the real world, it's quite a different story. So I think that is very important. We are very grateful for all these strategic partners of us who are patient with us and work with us and help us grow, and hopefully we contribute back to you. I think some of you are in the audience today, and I think there are also new industry partners that are coming today. Hopefully we can work with you again. So today we are at this stage to share with you what we have done, okay, and also maybe hopefully you can help us see where we should go next. So with that, thank you for coming. Let me introduce our director, the mastermind of all this, Professor. We need to say a little bit more.
All right, thank you. Thank you, CQ, and welcome to my distinguished guests, friends, colleagues, and all of you here. Yeah, we are very proud that we are able to have this first IDS open house, and it's time for us after 7 years to rethink about where we have been, what we have done, and where we want to go. So as CQ has mentioned, IDS first started with this. He tells us the vision, the mission is actually to bring together the different research, data science research in NUS across all the faculties, across all the schools together, so that we can pool our resources and to really work together to create real world impact. So you can see from what CQ has said, we are focusing quite a lot on not just coming out with new algorithms that can work on papers, but really to deploy it for real world impact. Yeah. So that is what we have been, you will be seeing at the open house later on, some of the projects that we are able to work with our partners to sort of like deploy some of these solutions actually for them to work in their clinical settings, in their work environment, to see some of this actually work is some proud achievement that with our hubs, with all of the hubs here that we are able to achieve. So our next vision is actually to make IDS internationally renowned. And we have started to talk to our international partners. And today's two of our speakers from US, from Canada, and we are also talking to partners in Europe that hopefully, eventually, what we have done here will also have worldwide impact. So that is going to be our next phase in IDS. And with this, really thank you for joining us today. I hope that you have enjoyed today and that the session will be informative to all of you. Hope you will take time later on to visit our booth outside to see some of the demo. All right, pass back to you. Thank you.
Thank you, Winnie. So today's program, we have two invited speakers, and then after that, please stay until the end. We have an announcement to make. And then, of course, after that, you can go out and look at our demos and posters. Although we have some funding, but our refreshment is quite humble, but still, please enjoy the refreshment. But more importantly, talk to our researchers and our students, okay? So let me proceed to the invited seminar now. So as you know, okay, I forgot who spoke to say this, but I always believe that the language is the pathway to human intelligence, human knowledge, human wisdom. So now we have entered this pathway, right, through to what happened last year with all these so-called advancement in large language models. So this is something, it's very important, and underlying is about data, unstructured data, and then how do you get meaningful, useful information for the machine to interact with us in an intelligent way. So I think we are now at the dawn of a very interesting era. We are now witnessing that, and this is a very exciting time to do data science, machine learning, and AI. So we have curated two invited speakers to talk to you about this topic. So let me introduce our very first speaker, who is Associate Professor Ben Hu Xia. Okay, coming all the way from Texas, USA, Rice University. So let me introduce Ben. Ben is an associate professor at the Rice University in the Department of Computer Science, and he is the director of the Center for Transforming Data to Knowledge, E2K Lab, quite similar to IDS. Dr. Hu has published over 100 papers, only 100 papers? Okay, in several major academic venues that you are very familiar with. Neuris, ICLA, KDB, I shouldn't say that, the web conference, Ichikai, AAA, and so on and so forth. But more importantly, I think he has contributed quite a lot of open source packages. He has an open source package developed by the group called AutoCarus that have become the most used automated deep learning system on GitHub with over 8,000 stars and 1,000 forks. And okay, I'll just not quite a long thing, right? But I think most important thing is that actually Ben was a student intern in NUS under Professor Chota Singh. So he has a good relationship with us. And I think we have all of you PhD students. Hopefully one day you also go out to the world, and then we'll invite you back to give an invited seminar at open house. Okay, so without further ado, Ben, the floor is yours.
Yeah, thanks very much for the introduction from Sing Kyung as well as the invitation. And it is my honor to be back after 14 years, actually. It's quite a bit long, okay? And at the time when I entered the campus today, I mean, a lot of memories just pop up. And again, it's very honored to be here and to introduce our recent development of the research about ChatGPT.
Yes.
It's now. Okay, now I will start.
Very well. You're coming up soon.
That should be okay. Yeah, I can talk. So as we know, since it's like a release, ChatGPT just attracted a lot of attentions from academia, from industry, and everybody is excited about, I mean, the possibility of ChatGPT like transforming the society and the as well as the technical community as well. And today, I'm not going to talk about ChatGPT from its like a foundation, from algorithm system. Mainly, I'm going to talk about from practical way, how ChatGPT will be helpful for our research, how ChatGPT will be helpful for our society, as well as like potential applications and the limitations of large language model. Okay, again, my name is Ben from Rice University. Unfortunately, it's not working. I may need this to be working.
Yeah, working.
Okay, cool. Yeah, today's talk will be mainly categorized into 3 components, including the capability of ChatGPT and applications as well as limitations. Please note that here, although I use ChatGPT as a terminology, however, I mean, behind that, there are a lot of like different versions of large language models. That's why I will use this ChatGPT as a kind of a general notion of large language models as well. And especially there are many, I'm going to talk about a little bit about this later, but there are a lot of like closed source and open source versions of different types of large language models. What ChatGPT could do? Okay, so if not all of you, I believe most of us have tried ChatGPT before. And here I would like to show 2 quick examples. So for example, we will be able to ask ChatGPT to like write a programming code for us. And for example, we can say, can you show me an example of bubble sort? And the ChatGPT will return very nicely curated like examples. And also you can ask a large language model to say, help me write a short note to introduce myself. And in addition to that, a little bit different from traditional like language models, we will be able to interact with ChatGPT, such that you can ask, hey, how about give me a more a shorter version, a more brief version, an abstract version of the self-introduction. And these are like a basic usage of ChatGPT in our daily life. And actually, all of these kind of very nice interaction and very nice results are based on a technique called transformer. Attention is all you need, which was published in 2017. And after its release, although we have been aware of ChatGPT very recently, however, over the past 7 years, the whole technical community are just intensively investigating transformers for different purposes, not only for chatbot, but also for many different types of applications in natural language processing, computer vision, social networks, and so on. And the key point of transformer here is like a self-attention mechanism allows the transformer-based models to capture long-range dependencies much more effectively than traditional models, such as recurrent neural networks. And here, if you are not familiar with the technologies of transformer, that is fine. However, most of us, we are familiar with machine translation, right? Here, I would like to make use of an example from machine translation to show you how transformer really works. We have the input from a foreign language, and the transformer is to work like a black box, such that it will transform it to like English as an output. And inside the transformer, it is constructed as multiple encoders to like really trying to understand this language. And we also have decoders trying to like kind of like map the original input into this output. And this is a basic, very high level mechanism how transformers really work. If you are interested in digging into more technical details, we don't have much time to really go through it like very carefully. And you can refer to this 2017 paper. However, because I was invited to just give so many talks about how transformer, how large language model really works, that's why I have had a hard time to really try to explain transformer in an intuitive way. I asked the ChatGPT, what should I do? Okay, how to really explain transformer in an easy way. And it provides very nicely curated answers. And let me explain them like in a more detailed level about transformer, okay? So we have encoder decoder architecture, and I can read the first bullet item for you, okay? Think of the transformer model as a language translator in a United Nations summit. The encoder is responsible for understanding the input language, listening, and processing, while the decoder generates the translation in the desired output language. Okay, very nice explanation about how this kind of encoder decoder architecture really works. And then similar to this, it also explains like a self-attention mechanism, multi-head attention, positional encoding, layer normalization, feed-forward neural networks, residual connections, one by one, and very nicely using real-world examples in an intuitive way. And now, I mean, I was so impressed by the capability, how ChatGPT could really explain how it itself works and in an intuitive way, much better than a data science veteran. Okay, so this is very impressive. That's why you can see the capability of transformer. It can do a lot. Okay, I would like to also emphasize there are like very nice properties, technical properties of transformers. For example, it allows like a parallelization. Because of this self-attention mechanism, it allows like we will be able to process language as tokens instead of like we have to rely on the dependencies of languages like similar to previous deep neural networks, such as those in recurrent neural networks. Also, because of the residual connections, transformer-based models will be able to deal with the vanishing gradient problem very nicely. That's why the performance is very good. However, again, it's a very, I would say it needs a lot of comprehensive background knowledge. If you are interested in transformers, this is a foundation of this wave of large language models. Please refer to a lot of just a lot of online materials and tutorials. You can take a look. Next, you may have this question. Transformer was like invented in 2017, and since then on, just a lot of companies, they have released different versions of commercial and open source large language models. But why ChatGPT is doing so well? And what are the secrets behind the ChatGPT comparing to many other models? Is it magic, or it's like there are some like engineering and scientific like insights behind the ChatGPT? Here, I would like to introduce what are the engineering secrets which power the ChatGPT, at least to make it at this level of performance in this way. Okay, here please note that most of the material, because like the technical details of ChatGPT are not fully revealed by OpenAI, although they claim they are very open, but actually it's not the truth. So that's why most of the technical contents I'm going to introduce today, they are based on the revealed documents by of InstructGPT, which is considered as a sibling model to ChatGPT. Okay. And to train an InstructGPT model, the core technique is called reinforcement learning with human feedback. And it can be roughly divided into 3 steps. The very first step is to collect human written demonstrations on prompts submitted to the API and train supervised learning baselines. And it works in this way. So firstly, a prompt is sampled from our whole prompt dataset. Prompt is like the way how you interact with a large language model. Here we show an example. Try to explain the moon landing to a 60-year-old. And this is an example of prompt for ChatGPT. And then a labeler demonstrates the desired output behavior. So here is the very first trick I would like to mention why ChatGPT is working on so well. Because like they somehow organize, collect, model, and integrate human feedback very nicely in terms of like providing response, the very nice response or desired response to this specifically sampled prompt, such that they will be able to learn a supervised learning model to fine-tune GPT-3 results. And this is the very first time, ChatGPT introduces human feedback into the process of training the model. The second step is to collect the comparison data and train a real-world model. The prompt and several model outputs are sampled. And specifically, what we want to do is like, okay, we will ask a human labeler to rank all of the outputs from best to worst. D, C, A, B. This is the ranking from human beings to rank the outputs. Which one is preferred out of like four outputted like results. And then the data will be used to train our real-world model. And remember, in the beginning we mentioned the trick behind the secret behind ChatGPT is called reinforcement learning with human feedback. And this is the second time how OpenAI is organizing, collecting, and model and integrate human feedback into the process of training ChatGPT, especially the reinforcement learning model as a real-world model. And the third step is to optimize this policy. Policy is a very specific terminology in reinforcement learning against the real-world model using this reinforcement learning architecture. And specifically, a new prompt will be sampled from this dataset, and the policy will generate an output. The real-world model trained from the second step will be used to calculate a real-world output for this like output from the last step. And the reward is used to update this policy using PPO, which is the algorithm in reinforcement learning. And as we can see from these 3 steps, so they very nicely employ human feedback and integrate and model this and integrate this into this whole process of training using a reinforcement learning architecture. And with all of this, I would say more like engineering efforts, we will be able to like push ChatGPT into the next level of success comparing to previously released large language models. And this is very nicely done, considering like how we can better engage human labelers, how we can really make use of human knowledge to be used in the process of training a machine learning model. And that's why, still there is a lot of like debate or controversial discussion among the community, saying like how much the technical contribution is from ChatGPT. But actually from my very personal and biased understanding, ChatGPT is so successful mainly because of how we can very well nicely organize human efforts, which is very important to push the last mile of success for many machine learning and AI models. After seeing like how ChatGPT is really constructed, I would like to, as we can see from the title, an experimental investigation, right? That's why I'm going to show you a lot of like experimental results, and not only done by my group, but also, for example, this piece of results is from another research group. And the first set of results I would like to show is performance on a very traditional and classic natural language processing task for the text summarization. Basically, what we want to do is like to input an article, and ideally we are able to have a very nice summary outputted by our machine learning model. And we compare ChatGPT zero-shot performance, meaning like we don't do anything for ChatGPT. We just use a vanilla version to get the results to see how it really works. And ChatGPT has never seen the data before, has no idea about what the data will be taken by the model. That's why it's called a zero-shot. We compare this with previously fine-tuned results on the summarization task. Fine-tuning results mean like the model has a basic understanding of what the data will be looking like. For example, here we compare with like 5 different types of data sets, ranging from very specific biomedical data sets such as COVID-ET, which is basically some literature about COVID, and also some of the data sets are like a general domain data set, news articles such as QM-SUM and QM-SUM Golden. And these are like collected from general domain for news articles. And we compare the 2 models over different types of standard metrics, such as 1 character overlap, R1, 2 character overlap, L character overlap, and they're like, and put everything together. And as we can see from this table, so some observations we will be able to make is like ChatGPT achieve comparable performance with traditional fine-tuning methods, such as like, as we can see, especially for general domain, it may like outperform fine-tuning model in general data sets in the news domain. As we can see from QM-SUM and the QM-SUM Golden data sets, ChatGPT actually, even without seeing the data before, okay, zero-shot performance, it achieves very competitive results. Unfortunately, it's not perfect, right? From the first data set, COVID-ET, ChatGPT is not working as well as a fine-tuning data set. It is believed that the reason behind this is like still, ChatGPT is like an expert. It has seen like just so many articles in the library. However, for some of them, for example, very vertical articles, such as COVID-ET, such as like biomedical literature, it may not necessarily be able to see them before. That's why, although it's a very smart people, it will just read so many literature, but it's not perfect. So for some like a very constrained, specific data set, it still cannot perform very well. And these are the constraints. Another task I would like to mention here is called machine translation. And also we compare ChatGPT with other commercial systems, such as Google, DeepL, and the Tencent systems in terms of the translation task. For example, from Germany to English, Romanian to English, Chinese to English, and so on. And from this set of results, we will be able, and it is compared according to the, it's called a blue metric, which is a metric to say, okay, how much overlap between the outputted outcome comparing against the gold standard labeled by people. Okay, from this result, we can see ChatGPT is comparable to commercial systems in translation tasks with very rich corpus. For example, for the task with a lot of open and public resources, such as English to German, because it's not surprising, we will have a lot of like articles related to English to German, right? That's why it performs very well, even for zero-shot performance. Okay, however, it performs poorly in tasks with less corpus. For example, from Romanian translated to Chinese, we don't expect to see a lot of this kind of corpus in public domain. That's why ChatGPT has no or little chance to see this kind of translation. That's why it performs very bad. Okay, and the conclusion we will be able to make from this standard evaluation will be, okay, ChatGPT is good in some like general tasks, but it's not perfect. That's why we consider it's promising, but we do not necessarily need to worry about ChatGPT's performance against the many commercial systems. We still prefer to use like a Google Translation or Tencent Translation in our daily life, right? I thought this way, like probably even a couple of weeks ago, from this set of very serious scientific evaluation. However, I had a very like a kind of eye-opening discussion with one of the leaders from this domain, working on machine translation. So I have never worked on machine translation by myself. That's why I had a conversation with them after one of my United talks. What I learned, actually, I was a little bit shocked because what they told me is like, although from the standard evaluation, from this kind of very serious experiments, we can say, oh, from traditional NLP tasks, NLP metrics, ChatGPT is okay, but we don't need to worry about that too much. However, they have done intensive like user studies internally. They have set up another metric in terms of user satisfaction, in terms of whether people are happy or unhappy about the translation results. And the ChatGPT is way better than traditional like machine translation models, mainly because ChatGPT is so like has done a lot of intensive efforts trying to like make this outputted article very smoothly read by people, and they consider people in the loop of training this whole process. That's why it's not that surprising after learning the results. ChatGPT's outputted results will be much better than those like commercial systems, which may or may not be very consistent and easy to read, right? Everybody has, I mean, most of us have been using like machine translation systems before. And we can see there are some like breaking sentences, there are some like unreadable outcomes from the machine translation systems. However, they are working extremely hard to change their architecture from traditional ones to transformer-based models, hopefully to make this much more user-friendly and much more readable. Yes, please. Oh, yes, that's a very good question. Actually, most of the results are based on ChatGPT 3.5, GPT 3.5, yeah. And because we haven't had a chance to really test GPT-4.
4 is much better than 2.5.
Yes, that's right. That's right. Yeah. So this is a very good question. Actually, I told some of my friends. So previously, if I prepare one set of slides, I can use that for over a year, no problem. People are happy. But now it's like I have to update this every couple of weeks. Every time before I give a talk, I try to like integrate some like new contents I learned from archive, from social media, from different channels, try to integrate into my slides. Yeah.
Now you talk about the low source language like Romania to try English, right? But you can actually fit ChatGPT with a plugin on that anyway nowadays. So then the problem doesn't exist.
Yes, that's right. That's right. And again, the results are based on some like previous evaluation, and actually this set of experiments is not done by my group even. We collected the best results in the market. We tried, yeah. And especially what I wanted to present here is like the results like from a scaled level instead of like I can surely test it like within 5 minutes for some basic understanding, but these are not like compiled results based on scaled experiments. Yeah. And here are some like a conclusion or summary. We want to say what are the use cases and the non-use cases for ChatGPT. And they're very good at creative and complex tasks. For example, coding and creative writing. And for also for some tasks with limited or no labels, fine-tuning a smaller model is typically very challenging or impossible to match GPT-3's 0 or 1 few shot performance. Also, it is very good at some like knowledge-intensive tasks, such as those like question answering, or in some of the applications. We really want our model to be able to mimic human beings, such as chatbot, because this wave of large language models, they just paid a lot of efforts, try to be user-friendly, try to mimic human beings. That's why chatbot is a very nice applications of these large language models as well. However, it's not perfect. We don't need a ChatGPT in all of our applications. And for example, in some of them, when we feel like it's very expensive, or we have a lot of like privacy concerns to make use of OpenAI ChatGPT API, at that moment we may not necessarily need to use ChatGPT, because we intensively work on biomedical applications, and later our fellow speaker Ray will also introduce some like healthcare applications. Actually, when we work with the hospitals, they have a lot of concerns about privacy. They do not want their patient data to be scanned, to be potentially or possibly leaked to OpenAI. That's why, although ChatGPT shows a lot of very promising results, I mean, they just cannot tolerate any risk of leaking data to OpenAI. That's why these are like no use cases. Also, similar applications are related to, like, for example, financial domain and any domain with sensitive data sets. That's why many people are working extremely hard trying to push the open source large language models to be able to use by these entities. And also, some of the tasks, they have been there for decades. And eventually, over the years, we have collected enough number of label data. And we will have already an established local model. In this case, we may not necessarily need ChatGPT. And yeah, very recently, we have published an article about a summary of like, we curated a very nice decision tree about what kind of applications you are working on. Should you use like a large language model, or should you use like a locally refined model? And it was like released very recently and attracted a lot of attention. I will leave the reference at the end of this presentation. Okay, next I'm going to introduce some like applications, how we can better leverage ChatGPT, even though sometimes we are facing privacy concerns. And what I want to introduce today is like ChatGPT for clinical text mining very quickly, related to two tasks. One is called name entity recognition, and the other is relation extraction. These are two fundamental tasks which can be used to generate a so-called knowledge graph. Because basically what we want to understand is what are the nodes in a knowledge graph and what are the relations between the nodes. And here we show an example, a 44-year-old man taking Paxlovid, experiencing like hives, troubling swallowing or breathing. And from this sentence, we will say some name entities. For example, the medication we are taking and the symptoms we are experiencing. And these are the name entities we try to identify. And also, our goal is to extract some relations between those entities. Because of some of the drugs, it costs some like, it is related at least. It is related to some symptoms. And okay, an intuitive way of using ChatGPT will be, hey, how about we ask ChatGPT to like identify those entities or relations? That's why my students, they have tried like a careful prompt engineering to say whether ChatGPT will be used to directly tackle the problem. And here we show like examples of using ChatGPT for NER task and relation extraction task as well. And unfortunately, we didn't get very good results. And also we have conducted some like very scalable experiments to have a better understanding of ChatGPT's performance on NER task and RE task on these two data sets, NCBI and GAD data sets respectively. And by comparing with ChatGPT with another large language model on vertical domain, BioBERT, as we can see, ChatGPT does not, achieve the much worse results comparing to BioBERT on the NER task, such like 31st comparing to like 88. It's much worse, right? It's not even usable. And it achieved like a comparable, reasonable results in the relation extraction data set. Please note that ChatGPT here, it is a general model. It is not fine-tuned for a specific domain, but BioBERT it is considered as a vertical expert on this specific biomedical domain. Okay.
So I thought ChatGPT also trained on some medical checks, right?
Of course, yeah.
To pass the US medical exam, so I thought that.
Yes, so there's no doubt ChatGPT has paid a lot of efforts and has been exposed to some biomedical literature. That's for sure. However, my whole point here is like it's zero-shot performance, and it is not fine-tuned based on some specific data sets. Comparing to, I strongly believe, thinking about the size of the training data or the way how it is exposed to biomedical literature, it's not comparable to BioBERT or similar models. Yeah, that's my whole point. It's still considered as a general model. And that's why we were thinking, directly using ChatGPT is not that promising, and it's not like the performance is not comparable to like models such as BioBERT. Then what should we do? And we do not want our data in the hospital to be leaked to OpenAI. We just want to like leverage the capabilities of ChatGPT, but at the same time, we want to preserve our privacy. That's why what should we do? Here we just come up with a framework which can be roughly divided into 3 steps: prompt engineering in blue, data generation in yellow, and fine-tune the local model in red. As these 3 steps, the first step is like we try to perform some careful prompt engineering, such that we will be able to like help ChatGPT to generate some to generate some very nice synthetic data, and which can be in combination with locally labeled data, which can be used to further train a model. And hopefully, this kind of generated synthetic data will be able to capture the main distribution of the data we are targeting, and it will be helpful for training a local model. And as we can see from this whole process, ChatGPT has never had access to our own local data, right? Basically, we will communicate, interact with a large language model using prompts, and we do not need to tolerate the risk of like leaking our data, and we perfectly preserve our privacy. And at the same time, because of prompt engineering, we will be able to interact and communicate with ChatGPT such that we will be able to leverage its capabilities in helping us to train a better local model. That's a basic idea. And here we show an example of the prompt engineering we do. For example, we will ask ChatGPT to generate 3 positive examples followed by 3 negative examples for the gene disease relation extraction task. And very nicely, it will generate some like synthetic data. They are not true data. They are just fake data with some like possible label information. And we as human beings, we as like domain experts, we will be able to make use of prompt engineering to help ChatGPT to generate high quality synthetic data. And later, this kind of synthetic label data will be used in combining with locally manually labeled data sets to train our local model. And the performance is pretty good. As you can see, we achieved like 45% against the 31% original vanilla ChatGPT version, and significantly improved the vanilla version of ChatGPT in our local tasks, and while preserving our perfectly preserve our privacies. And the conclusion here is like we will be able to improve the vanilla ChatGPT by leveraging its capabilities as well, and at the same time we don't need to worry about the privacy concerns, and which is very nice, especially for data sensitive domains. Okay, the last part of this talk, it's kind of like beyond the, it is related to the technical community. However, it is very much concerned by the society because of the too good performance of ChatGPT. Because many people worry about the misuse of large language models for this kind of very bad like applications. And people really worry about whether the use of ChatGPT will completely destroy our education system. And I can use a parallel example. Another example. For example, when I was a little one, when I was a child, my father told me like, hey, sound. So you need to really practice your handwriting very well. This is one of the main channels you communicate with people, right? Because at my father's age, I mean, the first impression, everybody will be able to capture is to say, hey, this guy is very good at, writes very well in terms of handwriting. But now it's really another age. So in my office, it's really hard to find a pen even, right? That's like just after 20 years because of the use of computer technologies. That's another example. And here, after 20 years, to our kids, do they really need to learn how to write an article? That's a big question to the society. And the people also at the same time, we're also worried about the use of ChatGPT. Will this like completely destroy our, destroy like the copyright of the articles, the copyright of our art work? And people really have a lot of concerns because of this. Many, not only schools, but also some countries, they ban the use of some institutions, companies, even some countries, they completely ban the use of ChatGPT. And then a question like raised to the technical community is like, if we will be able to identify machine-generated texts, then we will be able to somehow make sure this beast will be under our control, right? If we are able to really understand what articles, what texts are generated by machines, we will be able to not only good for our end users to better adopt ChatGPT in their daily life, but also very good for like system developers and the researchers to be able to trace the generated texts and prevent unauthorized use, and also understand protect our intellectual properties as well. And here, what we want to discuss briefly today is like how we will be able to identify whether the texts are machine generated or not. And here there are two main categories of methods developed to power this, which can be categorized into white box and black box detections. And here the idea of white box detection, the assumption here is like we will have access to those like large language models. We are developers. We are able to manipulate those parameters. The idea here is like, hey, how about we insert a watermark into this into the process of generating texts, such that later, if you want to like detect whether this text is generated by machine, we will simply examine whether or not it has a watermark. Okay, later I'm going to introduce how to really insert a watermark into the text. But this is a high-level idea. And the high-level idea of black box model is like, hey, although ChatGPT is very powerful, but it's not perfect. Okay, we will be identify some like clues, very subtle clues inside the texts to distinguish whether it's like a human generated or machine generated from, for example, some like language statistics, language patterns, factor verification, perplexity. From this natural language processing metrics, we will be able to distinguish. And firstly, I would like to have a quick introduction about white box detection. Actually, the idea is very simple. What we want to do is like, because like a vanilla ChatGPT, they try to generate words from a vocabulary, right? That's a basic idea of language model. And what we want to do is like, instead of doing this, we will maintain like two vocabularies. One is red vocabulary, the other is green vocabulary. And we will force our own large language model only generate the words from the green list. We try not to touch the red list of words as much as possible. Okay, we will force them to try to generate all of the words as long as it works. Okay, from the green list. Then the generated texts will be largely dominated by the words from the green list. The more words from the green list, it means the higher probability this text is generated by machine. That's the basic idea of using this kind of manipulating the way how large language model generates texts to insert a very clearly defined watermark. As we can see, if we see a text like this, we will be able to distinguish, oh, likely this is generated by a machine. And the idea of like a black box models currently is very intuitive as well. As we know, ChatGPT tends to be perfect. Okay, it tends to like write optimum text. That's why they are like just too sophisticated, and they try to use the best words they will be able to generate. And we human beings, we have different background, we have different culture, we have different education level. That's why the texts prepared by human beings tend to be very different. And because of this observation, that's why ChatGPT tend to use a small number of perfect words. And human beings tend to be very different, from very good writers to very bad writers. And because of the different distributions, this kind of subtle signals will be able to capture by natural language processing metrics. And we will be able to, based on, it's called a perplexity, to measure this. And we will be able to ask human beings to label some of the data sets and build up a classifier, which can be further used to identify whether the texts are human or machine generated. And here I would like to present my personal vision, how this will proceed, whether or not we will be able to identify machine generated texts in the future or not. For now, okay, at this stage, both black box and white box models would be able to work perfectly to, have very high accuracy to detect machine generated text, no problem. And in the near future, when our large language model is becoming better and better, okay, when ChatGPT is evolved in ChatGPT v2, v3, v4, it's becoming way better than now, and it can mimic the performance of human beings. It will try to pretend to be a bad writer, to be a well-educated writer, to be a writer with like a biomedical background, and so on. Then at that moment, the black box models won't work, will not work. Okay, it will fail in the near future. Because of the advancements of large language models, I don't think this will take too long. The black box models will not work, and only the white box models will work at that moment. However, unfortunately, as I mentioned, or luckily, I don't know whether this is unfortunate or luckily. So many companies in many entities, they are working extremely hard, trying to like push the efforts of open source large language models. That's why in the longer future, when open source large language models is as good as those like commercial large language models, it will happen someday. Okay, and everybody will have the access to large language models, powerful large language models. Then everybody will have your own large language model. At that moment, no one can really insert a watermark to your own large language model. At that moment, we really need some new like laws or some policies to regulate the use of large language models. Unfortunately, white box models won't work because like you will have your personalized large language model, and other people will not be able to distinguish whether it's prepared by yourself or your large language model. That will be very difficult. And in addition to the possible like misuse of ChatGPT, we are also facing some safety issues of large language models. As though they continue to develop just so rapidly, we are facing different types of concerns, including the hallucination, some like harmful contents, as what we show here, how to use a knife to cut myself. And unfortunately, some of the ChatGPT is doing pretty well. Okay, unfortunately, some other models, I do not want to mention the name. So some of them, they are good, some of them, they are not that good as ChatGPT. That's why they tend to still provide the guidance about, some harmful contents available in the model. And also, there are some like other higher level concerns, for example, the behavior of power seeking or multilingual capability disparities. While some main language models become more and more popular, some like minority languages, will they still be able to like really be competitive in the world or not? This will, cause a lot of other societal problems as well. So still, large language models are still in the very early stage. However, we just see a lot of potential of these technologies to transform our society. not only technical society, but also our daily life. That's why, I mean, we are excited about the developments, but we are also very concerned about the developments as well. So that's pretty much my talk today. And most of my contents covered in this deck of slides are from these 5 papers. Some of them, they are survey papers, and some of them, they are recently published technical papers. Again, thanks very much. And any comments and suggestions, questions are very welcome. Thank you.
Thank you, Ben, for very exciting talk. Some time for some questions. And those of you who want to take a toilet break can also do that now. Yeah.
Yes, please.
So I was wondering when you showed results of using soft prompting or ChatGPT and getting the results better on this domain, but those results are still quite worse than the bio, right? So it has very good observation. And then the second point is, you can do better there. Why don't the same technique and bio work more rather than ChatGPT?
Yes, that's one of our ongoing work. We have a base that are piece of work. That's a very good observation. So the question, I want to repeat the question just in case. So we have generated some synthetic data, and they are used to, I mean, in combination with some local methods, and they work pretty well and better than originally vanilla version of ChatGPT. But the question is, are we able to combine this generated synthetic data with some local established large language model, and will we be able to improve the results of the local large language model? It is possible, but it's not. I mean, it's not good yet. We're still working very hard to see whether that's possible. Because it's not exactly like going to directly make use of the data on top of environment. It takes some effort.
So I was going to say that it seems, yeah, like I understand you all this. Basically, because training ChatGPT is easier by using RLHF, it's basically the idea of how easy it is for you to go and train some and make it easier to find the question. The other was about, so I had one more question, it was about the classification task for whether it's a generated text or not, right? I think the bigger question with respect to the subjectively trying to say is not that what will work, what will not, but probably I think the bigger problem is around what you will do with false positives, because when you start using it and you start accusing someone to use something when they have not used, that's where it becomes more important. And that's where also you have higher impact of, because you are accusing someone who will not be able to come out and say that they have actually used it. And that's where probably the problem lies of where we are going with.
Yeah, that's a very good question. So how we're gonna really deal with false positive? For now, what we could do is just to really increase the cutoff value of determining whether this is machine generated or not. So we will try. I mean, this is the best we can do, but we cannot. I mean, I don't know whether we will be able to really achieve the 100%. I mean, in terms of false positive, that will be 0%. But I mean, the best we can do now is to really improve the bar of a cutoff value to say we're pretty sure this is machine generated. Then we will be able to accuse someone.
Yeah, then that goes back into the question of, because you will go back into space where you will have so many language models, so many personalized language models. That never it becomes a chicken egg problem.
Yes, yes. And another way probably is to construct an ensemble learning model for large language for detector models. If all of the we can possibly form a community of models, detector models. If all of the models determine this is machine generated, and it has high probability, I believe. Hope this answers your question. Okay, cool. Any other questions?
Okay. If not, thank you, Ben. Ben will still be around during the tea and all these things engagement. Actually, I think you'll stay for a few days. If you really want to meet up with him for other one-on-one session, please drop us an email for Ben and me. All right. Thank you again, Ben. Thank you. So let me introduce the next speaker. He's already standing there and ready to give a talk. So Professor Raymond, also a friend, a long-term friend of NUS, IBM. Raymond is a Canada Research Chair of Data Science and Analytics, comes from University of British Columbia, very far away Canada. He's also the founding director of the Data Science Institute, our sister institute in Canada, at the University of UBC. So he's an elected fellow of Royal Society of Canada. Yeah. But I think it's quite interesting. He was named as one of the world's top 75 academic data science leaders 2022 by the Chief Data Officer magazine, which grew out of the MIT Sloan School of Management. But more importantly, Raymond's research area has been contributing for the past 3 decades in data mining with a specific focus on health, informatics, and text mining. He has published over 220, more than that, huh? 220. Oh, keep it up, okay, the competition. Peer review publication, and so on and so forth. So yes, we are very happy to have Raymond here today to also talk about a little bit more on natural language processing and healthcare applications. Yeah, and yeah.
Thank you. So thank you for inviting me. I have given a few talks at NUS, over the years, the Department of Computer Science, the medical school, and this is the first time that I give a talk to this audience from the IDS. So now, there are good things and bad things. I mean, not bad things, but there are pros and cons for me to follow Ben. The good things to follow Ben is that he had given such a good introduction about large language models that I think I could maybe skip one slide in my talk. But the con side of following Ben, and I want to kind of realign your thinking about my talk. So my talk is not about ChatGPT. And in fact, my talk only a little bit about large language models. So my talk is a lot more general about natural language process. And I hope, I know that there's a good component, of you that also do NLP, and I'm sure you'll agree with me that ChatGPT is not exactly NLP. Either. And so I'm actually focusing more on the more general NLP side. And in fact, the most important, difference between my talk and Ben's talk is that I'm going to take a very deep dive into a very important application domain, namely healthcare. And Skong, talks about the vision of IDS. And the last few words, he was talking about real life challenging, problems. And so there's not too many real life challenging, problems than, life and death and human suffering because of illness. We went through 3.5 years of COVID. We know what health means. We know what public health means. And so in a way, I think, the healthcare domain is a very important area, not just for ourselves, but definitely, for the society, as a whole. So that's the nature of my talk, that I'm going to focus on healthcare. So I'm going to come to this question, and I'm going to say that I'm going to answer. I need a point. No. Press down, going forward. Yes. So I'm going to, I have 2 slides where I try to answer the rhetorical question of why NLP for healthcare. And this is the first answer. And then in a few slides later, I'm going to give you the second answer, why NLP for healthcare. So the first answer is that in the medical domain, unstructured documents is a gold mine when it comes to information about the patients. And there's a lot of what we call official documents, and they might be like medical reports, clinical documents of various types. Then there's also what we call user-generated content, blogs, text messages, social media, on one of his slides. So I will also talk about how in the clinical space it's very important not only to focus on clinical documents, official documents, but also user-generated content. So that will be in the second half of my talk. Now, machine learning, given its fuss and its advances, have been applied to healthcare for more than 10 years and maybe even 20 years. But for the most part, it has been applied to more the structural part of it, electronic health records being the primary example. So if there's one take-home message that I want to remember for my talk today, is to tell you the really huge opportunity for you to use NLP and apply it for better patient care. And so you could use that as an application domain, for your research, for your startup activities and whatnot. But it really is a very important and very fruitful, domain for us to deploy the tools. So let me give you a very specific example why this is such an important problem. And cancer care. And I don't know how many of you in your lives have experienced your friends or your family members going through cancer. And I hope not, but but life is life. Sometimes it's not it is not possible to avoid that. Now, and so I'm going to describe, 3 phases of cancer care. When someone, has some symptoms, and they will go through a diagnosis phase. In this diagnosis phase, there's all kinds of reports that got generated: X-rays, CT, biopsies, and surgery. Every single procedure generate a report. And so there's a lot of information being created by experts in the reports. Now, suppose that after that diagnosis phase, someone unfortunately is confirmed to have cancer, then they go through a treatment phase. And in the treatment phase, there's rounds and rounds of chemotherapy, there may be rounds and rounds of radiation. There might be surgery, and so, and again, every single step, there are documents. Now, let's just say that it works very well, for the treatment, but that's not the end of it, because there is another phase, which is post-remission phase. There's, routine checkup. There's, 1 year, 5 years, up to 5 years, but there will be other procedures. And suppose someone is unfortunately going through a relapse, and it happens, quite a bit for cancer. I mean, obviously it depends on the types of cancer. So if someone has a relapse, it goes right back to the beginning: diagnosis, treatment, post-remission. So my point is that in this whole process, if you take cancer care as an example, every step will generate so much useful data embedded in documents that are unstructured, and we have a difficult time actually using it in the healthcare domain, making decisions. So the current practice is that all these documents are very siloed, and oftentimes the documents are used very locally. Every single step, a clinician will be reading from the previous step and made a decision. And so the time frame of what they're looking at is typically very short, a few months and so on. But as I described in the previous slide, the whole journey of the cancer patient is like 15 years and even longer. So there's really no way, or there is really not a very good organization in our healthcare system that we collect all these documents and holistically build a picture of what we have known for this patient for 15 years, for 20 years, based on unstructured documents. Now, even if we have done that, the other problem is that right now in the healthcare domain, for the most part, a lot of these documents are interpreted and read by humans. And I mean, which is a good thing, but as we all know, particularly with aging in our society, the demand for for such interpretation is very high. So it introduced a lot of delay. And so the idea is that, well, this is exactly something that maybe we should automate. We should try to automate, even if the automation is not as accurate as a human, but imagine that it's much faster. In the cancer care that we now have, a lot of these documents sit in the BC cancer care for 6 months. And to process a document like this is probably like six seconds. So for cancer, 6 months is a huge amount of time, right? Cancer, some of the acute cancer, you literally could go, someone could go to stage 2 to stage 4, within a year. So if you lose 6 months waiting for a human trying to read the document for you, or maybe read the past 5 documents, a lot of times will be lost. And so the idea is that why don't we not use an algorithm to help with that process? So we have a program with the Ministry of Health in BC, where we try to do a lot of extraction. So Ben talked a little bit about relation extraction, and our work is a little bit simpler here because we're not thinking about general open relation. There's specific, what the clinicians say, fields of interest. There's all these reports, they have 150 fields of interest that they want to extract from the document. And once they've extracted it, then they could use it for improving detection of reportable cancer, understanding what is the diagnosis, should someone be fast-tracked because of the severity, and then at the end we even talk about relapse. So that is the idea of our program. Now let me give you a specific example, just so that I introduce the concept of fields of interest. This is a breast cancer surgical report. This is a real surgical report, and the report talks about all kinds of things. Some of the fields of interest that the clinician wants to know is, okay, do we find cancer? Where? How large? What is the stage? So I mark some of this, box. Okay, there's invasive ductal carcinoma, so there's certainly cancer, and about 1/2 of the specimen. So it is quite serious. This is a severity score. It's called the Nottingham score. The Nottingham score is 8 out of 9. It's grade 3. And how large? 2 millimeters. And then I also want to highlight the fact that this is not a search. So they cannot just use a search engine to search a report, because then when a surgeon was writing this report, the surgeon is writing in English. And so the information that they're looking for could be anywhere in the document. So typically a report would be like a 2-page document. So anywhere in this 2-page, the clinician will be describing, what they have seen, or the surgeon would be describing what they have seen, and then they write the report. And so, but then it's not only a search, because there might also be a negation. One of the important things when it comes to cancer is this idea that is called lymphovascular invasion, which is like how the cancer cell has already, invade. And so for this patient, is not entirely bad news, because it said there's no lymphovascular invasion. Now, negation, this is a simple negation where the negation no is immediately in front of the term lymphovascular invasion. So that is easy. But when humans write things, sometimes the negation comes like a few sentences later, or maybe the next paragraph. This is where it actually motivates the idea of transformer, because it's not necessarily local, where you could find negations and modification in language. So this is why this is a very specific example of how it could be. So what we try to do is, in fact, use an NLP power detector extract the field of interest. And in fact, what we do is simply take the data from the unstructured domain and move it to the structured domain. And then they know what to do. Because now, as long as we put it into the structured world, relational database, or even in an Excel, they know how to take over. What they need help is to get the data in unstructured document and extract them to the structured world. And so that this is really, so I'm just showing that this is some of the, 40 or so of the fields of interest, and out of 150 that they want. And I just want to show you that there's a very big diversity of what is called the fields of interest. So this actually ends the first 1/3 of my talk. Is there any question or comment before I turn to the part that I think connect a lot more with Ben? No? Okay. But feel free to go. So as I mentioned to you, I'm going to answer the question of why NLP for healthcare twice. Now this is the second time. My first answer was the unstructured documents in the healthcare world is a gold mine of information for patients, but we don't use it. The second answer is that, well, this is very timely because Ben has built a foundation, in his talk in the past hour on why NLP, and to some extent fueled by advanced system machine learning, this large language models, pre-trained language model has really been very, very impressive. Not just in a general sense, I'm also glad that he was showing BioBird because we actually use BioBird a lot. And we don't use ChatGPT, but we are using BioBird. But and this is a simple introduction of what BIRD does. And I just want to actually say that natural language processing is the name of the field. But we actually prefer it to be a little bit more nuanced because what we are trying to do is, processing, spell check is also, processing. You are changing the word, you're correcting, spell. That is NLP, in a simplest form. But what we're trying to do is really to do natural language understanding. And the word understanding is a lot harder. And I think Ben also was talking about, maybe Ben or Sikong was actually talking about how language is, is related to humanity. You are going to hear that in the second part of my talk. Language to us is a window to what the person is thinking and what the person wants to say, what the person feels, or what the person is not able to feel, or what the person is not able to feel. And so that's why to us, language is a very important, lack of a better term, in the medical field, it's called biomarker. To us, it's a huge series of biomarkers that we could sense. We're doing sensing of the person based on what is in their head. And so that is why we want to understand. So this, I'm saying this is because I'm trying to introduce how the understanding word relates to what we are going to see in the second half of this talk. So, Bert, I think I could skip some of this. I got this from a friend, and this is a very interesting evolutionary tree. It describes how the language models, how they are descendant of each other. So you can see that Bert is really early. Bert is really early on this branch, and then there are cousins like Roberta and well, actually Bert is here. And then there's Ernie, and then there's a new branch. You see GPT-1, GPT-2, GPT-3 and then ChatGPT. And the interesting thing about, so Ben also mentioned about open source and closed source. If it is unfilled in a box, these are all closed source, and whereas the earlier ones are all open source. What is really amazing, and I think what is really amazing to point out is just look at the y-axis. This is 2019, and this is 2023. This is 4 years. So it really is amazing how this language model business have exploded. And but I thought this is a interesting picture that I got from a friend, and I mean I'm not smart enough to generate this truth. So I think I could skip this. This is just a very quick introduction of what we could use a large language model. Is basically we use it to do question and answering. We use it to use what's called NLI, natural language inference, for us to do the extraction of the fields of interest. So for those of you who are a little bit more technical, I connect that to you. Now I'm going to change a little bit now because I want to talk about user-generated content, and it's really very important, not intellectually, but it's even in the healthcare world. And it is not something that actually has been widely used in healthcare because we don't know how to do it. So clinical documents are written by well-trained experts, radiologists, pathologists, surgeons, nurses, very well-trained. But why are we only sense? So we're talking about sensing. We obviously rely on the opinions of professionals. But at the same time, why are we ignoring what the patients have to say, what the families have to say, what the caregivers have to say? What do they prefer? What is their experience? What is their mood? What is their sentiment? And what are their needs? And so now UGC, user-generated content, from NLP perspective, is actually harder than a lot of the clinical documents, because people who are writing, patients and the families, they are writing, they're very diverse background, very different styles. They may not even be grammatical, very different length, and very, very subjective. And subjective is not necessarily a bad thing. Subjective could carry very important information, right? If someone say, I'm in pain, and I think this really sucks, that emotion is informative. So there's a very different genres from a natural language processing point of view too. And so the demand to do the right extraction, to do the right analysis is a little bit different when it comes to clinical documents. So this is why I'm very glad that there's social media on the, are very prominent in the word cloud. So listening to the patient. So we have 4 general tasks that is important. And I think when it comes to listening to the patient, first of all, what are the patients talking about? Are they talking about the diet, talking about the treatment, talking about the doctors, talking about the nurses, talking about the food in the hospital? So what are they talking about? And so that in natural language processing, for those of you who are familiar with the field, that would be roughly like topic modeling. And then there's the area that's called needs detection. What do the patients need? What do the family needs? Do they need support? Do they need health information? I'll give you an example later on the needs detection. And then what is called dialogue edge. Why are they talking about certain topics? Do they want to have information about certain things? Do they want to ask questions about, I have a skin rash after I take this drug. Is it a reaction? And so we want to understand why they are talking about certain things. And then this cost analysis. This is a very interesting aspect, particularly when it comes to neurology. This is about whether the brain. So we are trying to say, we're trying to analyze the text and see whether the patient is even coherent. Does this look like something written by a person who is sane, or maybe this person is insane? Maybe this person is getting insane. And this is exactly an illustration of what I said earlier, that how we use language as a sensor to what is in the brain, what is happening to this patient. And so this is, so I'm going to illustrate, we have done work on all the, all the 4 tasks when it comes to patients and, patients' conversations, but I'm just going to focus on needs detection. And I'll just show you a few slides where we're using the American Cancer Society online discussion forum data, and the task is just to detect the needs. And I'll give you a very 2 quick example. This is based on, typically, so this is actually based on this data set that is about 52,000 posts, and between 2006 and 2016. Now, the forum exists as we expect, there's Reddit posts and, all of them. But in the healthcare system, very few systems would have the resources to go and try to understand every single post, try to extract the information from every single post. So it's very labor intensive and it's very time consuming. And again, this is the kind of thing that an algorithm could actually be very useful to try to analyze, all these posts and maybe be able to, create an early intervention system, highlight certain posts as to maybe having a follow-up, to be able to build features like. So let me give you 2 examples. This is from the ovarian cancer online discussion forum. The first on the left-hand side is a post by someone, and it says, I finished 6 rounds of carbotaxol and I'm slowly recovering from the assault of the treatment. Has anyone experienced joint pain after treatment? I've noticed increasing pain in both hips and recently, knee pain. The sentence in red is not in the data. We color code that as red because this is like the attention mechanism. We identify that because of that red sentence, we classify this post as someone seeking, there's a physical need. This is a question about a physical need. Now contrast that to the next post. Someone said, I have 6 to 8 months of chemo. I'm so scared. I do not know what to expect. I'm having a hard time dealing with this and attending a support meeting. I have a difficult time staying positive and so on. And so because of this red text, the algorithm is classifying that as an emotional need. Someone needs some emotional support. And so this is 2 examples where we are using NLP. This was a paper that we published 4 years ago, and it is basically trying to do what we call need detection. The last thing that I want to point out is that at least for that data set, the cross-validation accuracy is actually quite decent. So it is possible that we could do work like this and be able to really understand what the patients are saying and maybe identify individual ones that we want to provide some more help. And I'm coming to the last part of my talk, and I really want to talk about psychiatry, because psychiatry is interesting that not only are the user-generated content unstructured, even the clinical documents are often unstructured, because psychiatric assessment doesn't have what in the healthcare system, they will call a case report form. So it's not a standard form that you fill out, okay, what is your blood pressure, what's your temperature. And so that part is, very structured. In psychiatric assessment, it's basically the psychiatrist writing a report, 2 pages, 5 pages, and it's unstructured. The clinical document is already text. And then on top of that, you have social media posts. And I just want to put it here that I think social media is particularly important for the younger generation, for Gen X, for Gen Z, because they actually use, so in essence, estimated that 85% of all youth are heavy users of social media. What they say in social media is important. I mean, now, even for forensic purposes, we will now go, the police will actually go back to the social media posts after someone has committed a crime. But imagine that some of these tools will actually help us to do early intervention. But again, it's very time consuming. But again, this is exactly the kind of thing where an automated algorithm would be very useful. So we have one specific project where we have 1,000 youth for this hospital. So for those of you who have been to Vancouver, there is a hospital called the BC Children's Hospital. And the BC Children's Hospital actually have a psychiatric branch. And so in this data set, we have 1,000 youths who have been admitted through this emergency room, for psychiatric emergency room, and due to self-harm. So they're not necessarily trying to kill themselves, but maybe they cut themselves and do all kinds of things to harm themselves. And the data that we have is the admission notes, and then they stay hospitalized, so there's a discharge summary. And for this particular project, we actually have permission to get the social media posts of the youths 6 months prior to admission. And the idea is that we want to try to build a model to do a risk stratification, which is to say, how likely is someone coming back in 2 months? And the data is all unstructured from the admission notes, discharge summaries, and of course the social media. And so we believe that there's actually a lot of very useful, very useful data for us to build a predictive model so that we could get more help to those who we think is more likely or higher risk to recommit the self-harm to themselves. So that's it. And I think this is maybe my last, it's not, the last part of a little bit of the technical work. So, psychiatry is not just about, people who have committed self-harm. In general, the whole idea of, mental wellness. And so we want to go a little bit further upstream too. We don't want to be just tackling, people that are further downstream, that are a lot more serious. And so we have been working. So there's a Health Canada funded project to monitor the mental health of university students across Canada. So there's UBC, University of Toronto. There's about 35,000 students who have actually signed up, and across Canada. And the reason why this project got funded was obviously motivated by the pandemic. And because Health Canada want to understand how the pandemic or the shutdown, and I'm sure all of you understand, and we understand too, as professor, how the pandemic has really changed how we come to the university, how we learn. And so this particular project is one way of monitoring some of that within Canada. one piece of it is to actually the user-generated content. So we want to understand. We want to understand a few questions. What do students talk about? Now, so this is like topic modeling. Many of what they talk about may be okay, may not be a concern. But specifically, are there things that really stressful? But specifically, we want to understand what we call the stresses. What is stressing our students? And are those stress getting worse? Are those stress getting better? And then there's also the regional, difference. Is it different across campus? Are the stresses at NUS different from the stresses at NTU, for example? So in this particular case, we want to be able to understand that. And so we have been building a platform that allow us to do this analysis. So this is a very simple diagram. You have Reddit posts, for example, we go through a language model and hence topic modeling. So this is why it's, related to language model. We do a bird topic modeling. We find out different topics. We find out what the representative sentences are. And the interesting part about this platform is that, so this is where the word link comes in. There are specific psychiatric, documents that we use. So we want to use those documents to kind of define what the psychiatrist will be interested in understanding who they want to identify. And so then you have the psychiatric document, you have the sentences, and then we are going to flag certain sentences as closer to what the psychiatrists are most interested in. And then we try to identify what the stressor sentences. Are people worrying about tuition? Are people worrying about housing? Are people worrying about jobs? Are people worrying about in the case of the pandemic, are people really worried about failing the exam and how they're going to catch up and things like that. So we have been building this platform, and the idea is that this is in the earlier slide. This is really a framework that allows a psychiatric analyst to do that online, so that they could actually look at the Reddit post, themselves. So this is really a online platform. So I think I have outlined for you how NLP could be very important in extracting from clinical document, analyzing user-generated content, from cancer to chronic disease management, and then lastly in psychiatry. And my last slide is that I have two final comments. And I think Ben already helped me with one, which is the multilingual aspect. The multilingual aspect is important within Canada because Canada has two official languages, French and English. English, as we all know, the large language models are all based on American English. Actually, it's not even English. It's not Singlish for sure. And but French and but what about Chinese? What about Japanese? What about Italian? German, and the multilingual aspect, particularly in user-generated content, is important. And I think the large language models, so Ben already talked about ChatGPT, is actually one of the ways that might be useful in actually tackling some of this multilingual aspect. So from text, and I just want to say that even though I've been talking about NLP, and we were talking about written text, I actually want to say that speech is important. So when I talk about NLP, I even broadly think about speech. In psychiatry, there's a lot of tapes. I mean, people don't type, they talk, and then they just tape it. They just record it. And so one way of reaching to that data is, well, you just transcribe it. So you transcribe it into written text, and then you apply all the machinery that we have talked about on the written text. But then there's also, you could also do signal processing to extract very important acoustic features. One of the most important features when it comes to some of this is silence. How long does it take someone to respond to a question? Right? I joke about, the fact that in a lecture, you'll say, okay, can anybody answer this question? Silence. Silence is a very informative feature. Or someone get angry, right? In a speech, or someone starting to talk louder and louder, or someone starting to talk softer and softer. All these are very important features. So we could extract all that data, including the NLP, but also have the acoustic, features, and then you could build models about them. And this is not just about psychiatry. In general, the society has been using, I don't know how many of you in the past few years have relied more on, Siri and Alexa. There really is a lot of data. I have, after I gave some of these talks, I have actually someone from the Autistic Society who actually came out because they were very interested in having taped the conversation between kids when they grow up playing at home, because this is the safest environment that they have. And they actually want those recordings to be analyzed, and they try to build an early detection of autistic, child. I have another person who actually think about using speech, and they were talking about postpartum, depression, right? So, mother has just given, birth, and many of the mothers actually suffer from depression. And the idea is that if you actually have some of the home tapes about how the mom interact with the baby, so this is not about the baby, this is about the mom, then you might be able to build a model that much earlier detecting that a mother might be undergoing depression. And so again, those data is there. And the fact is that how do we take advantage of that so that we could build very useful, application to fulfill the vision of, real life challenges. So thank you very much. I think explain a little bit about what happened.
No, I don't need this. So for giving a very good talk on the real life implication of our work from the technology that Ben has also introduced. In fact, you can see, I think we talked about data, so it's not just text, there's also speech, and actually there's also images.
Medical imaging is a big,
So all these doing all of them are is an interesting aspect. So data is everything, and data is also multimodal. So any questions for Professor Raymond? Silence. Okay.
I lost it.
Exactly. I think about it very right. And then what I would maybe want to do on data in the show. But when it comes to management work, I think one of the highlights that always complicated kind of language whatever. If you could design going forward, at least where doctors, are trying specifically having a team level based by the super question. How would you do? I appreciate it. Like the paper for you can just go and doing that. How would you do it? And do you think is it actually desirable? Is it actually desirable to do so, or do you think medical reports with international language somehow convey something that cannot be grasped there? Sort of
So that's a fantastic question. Actually, that kind of framework already exists in the Canadian healthcare system. The problem is that only 60% of the pathologies use that form.
Is that the older generations first one that use it, or the because you know the second new medical field along. Medical field is there, they actually they have applied once the new generation learn in medical school, gets the position and the older generation is higher.
I was told that the sociology is not say, you know, there are people who use the a lot of people use hate. This is one type of
Okay.
but then I think there's another very important aspect. You know, even if you have something, the open-ended text box, when you read it, it's the most important, right? Because so I mean, imagine that the pathologist goes through a certain set of questions, and all of a sudden the pathologist write 5 down something. Yeah. About that, but you better read it. Because there's a reason why they say it. And so I think even though we're not exactly that, that's specifically yes. We still need to handle
Just be the carry.
that's the most, you know, that is the goal. Yeah, so I think it's been
The push was more around the practical aspect. So when you really analyze this clinical report for the results of pathology, what you really realize is you end up getting roughly 5 words from them or 6 words. Like they're writing actually 5 lines is very rare. Like so, it's pretty rare. And even in their 5 words, these are technically most of the time acronyms that they end up writing, which again, even if you go and take bio, if you take even domain-specific language models, they actually don't have them because those domain-specific language models are trained on papers rather than the reports. So how you think?
well, so I showed you the example of lymphoblastic regulation. It is a process, and it's very important to all these. What bio they won't do. And so we do. I mean, we do find it works like that. And then in the future, we have to believe that once we are what we have been doing. The British Columbia is big enough as a government that I think we are going to lay out. This based on the cancer document, or based on clinical documents. So and then talk about BioBird. So BioBird has bird, and then with a lot of PubMed publications. There's a clinical bird, which actually where they actually has a clinical document. But these are generic clinical documents. I think in a few years' time, we will be able to try to convince the government to look, spend some money doing your own cancer, do the British Columbia cancer, and so that people actually be exactly tackling problems. I think we were doing a kind of like a free shot learning, fine tuning. I think eventually we really are going to use it for big time to have exactly as you said in some of them.
So the first one, trying to ask whether you think it is applicable for you to use things like BioBird or user generated content, because you know that the input data and chemical representation is very different. So those translation representation results from the user speaking something things like expression communication as well. So do you think that BioBird is kind of clinical this like on the user generated content? The second question is that I'm very interested in using like
So so for the first question, so the previous question was just talking about very specific medical things. And we talked about how the Bible may not put enough for that because it's a very specific window that the medical community. And now the first part of the question about user-generated content. I think Bible is actually good at it because typical patients and their family don't use the medical term, they use general term. And so in that sense, the more generic, I won't necessarily say the vanilla, but the more generic the language model might actually be sufficient. And I'll give you one specific example. One component of analyzing user-generated content is for sentiment analysis. And so there has been a lot of work trying to use sentiment analysis itself, as many of you know, predated the large language model. But in recent years, there's a lot of sentiment analysis frameworks that have been now enhanced with the language models, and I think they've been quite successful. So I think for the more general content, we have to use for analyzing user-generated content. Maybe we don't need as much fine tuning as in fact the more technical clinical documents. Second half of your question about how we want to deal with multimodal data. So you are using speech and you are talking about user-generated content, but I would take the we could be even more general. What about imaging data if you want to build a model? And I think if you are a completely neural network person, you will say, oh, we'll just put it in a neural network, put it in a deep network, and let it deal with it. And if you are more classical, you're a machine learning person, you say, well, I'm going to extract certain features from the from the tapes, and then I just put the feature set from multiple sources, the data, and then I could build a model, I could build a decision tree, I could build support mechanism. So that's the more classical view. Then you could say that, well, in a lot more classical statistics, you could do ensemble. And you could say that, well, what does the UGC data tell me about this patient? What does the audio, data, tell me about this patient? And then maybe you want to combine the probability whether someone is. So I think there's more standard ways of trying to deal with the multimodality of cognitive. But I think the important part of my talk is to say that once you cross the structured world, we have a lot more tools that have a lot more experience. What the world needs us to do is to cross from the unstructured world to the structured world. So we are just talking about how we could cross and extract from seeds, extract from images, extract from text, and once you bring them to the structured world, and so I hope that answers.
Okay. Thanks a lot for all the questions. So I kind of want to say at the end, I said earlier, language is the pathway to humanity. So a lot of this data is what humans are thinking, what humans are feeling, what humans understand, and all this. So so I guess now that we're breakthrough with language, I think it really opens up the pathway for us to understand all this other data. Okay. So since I'm the host, I get to say the last word. All right. Yes. Okay. Thank you very much. So can I? We move on to the last part of this seminar. Can I invite Raymond and also Winnie to be on stage? We want to announce something that we are working on together. So can I have the next slide, please?
Yeah.
So this is we talked about moving towards the international stage, right? So we are about 7 years old now, so we want to move towards the international stage. So we have this. We are very happy to announce this so-called initiative that we have actually been discussing with Raymond for many years. So we're glad to see that it comes to fruition and glad to see that you are here to see to kind of officiate this initiative. So it's about establishing an international profile and certificate network in data science in a global setting. So what is this about? Maybe I'll ask both of you to kind of press some thing here. Okay.
Press something here.
Yeah, okay, all right. Yeah, yeah, okay. Yeah, okay. Please, so
I think we need music.
yeah, no, so, actually, one music, I want PhD student doing a music generation. So this is our new program, a postdoctoral exchange program with UBC. Can I go to the next slide? So we have talked about it. We have secure funding on both sides. For those of you who want to join us as postdoc, now you have the opportunity to also continue your postdoctoral training with Raymond at UBC site and also vice versa. We're also looking at PhD exchange. So I think it's very important for all our postdocs and students to have international exposure. We want interdisciplinary exposure and now also international exposure. So would any of you want to say anything? Maybe Raymond, you want to say anything to sorry, put you on the spot. Yeah.
Well, I mean, we think that the motivation, the key motivation of this program is that I think when we look at, I don't know about NUS, but UBC actually has been doing a very poor job when it comes to mentoring or enriching the experience of our postdocs. And the postdocs are the most highly skilled research staff that we have in our ecosystem. So the motivation of this is to be able to let the postdoc enrich the experience by not just working in one location, but working in 2 locations, 2 systems, 2 projects, and 2 beautiful cities. And we hope that, this is not a program for everybody, but for the ones who really want to try that, I think it will be very attractive for UBC postdocs to come to Singapore for 1 year and vice versa for Singapore postdocs to go to UBC and work for 1 year. And even though Sikong, mentioned my name, this particular program is not mine. The whole Data Science Institute at UBC has about 30 faculty or so. It's very interdisciplinary. You have people in not only in computer science, in math and statistics, but also in medicine, in arts, all kinds of areas. So we really want people to be able to apply to this program so that they could try to find a suitable supervisor for what they want to do. So yeah. Thank you.
Yeah, so we are starting with the postdoc exchange. We are also looking at the PhD student exchange, not just with UBC, but also with Germany soon. So it's an exciting time forward.
Yeah, and all this in time for the pandemic. That's all. All right, but it's really good, going to be a great period for all of you. I think please tell your friends, tell everybody. All right, thank you. Thanks, Jeannie, and thanks, Raymond. So let me introduce the next. Basically, please go and take a look at our. In fact, they've been waiting for a long time. Our postdocs, our students. Out there, you see all the exhibition. We really want to tell you right outside here is our PhD program. Actually, IDS has a very interesting PhD program. It's interdisciplinary. Our students can be from computer science, can be from business school, engineering, even health. In fact, we also have a faculty that's for multiple disciplinary. So please take a look at some of their work. They have been waiting for you for a long time. So they're also, like I said, there's one that's on music. It's quite interdisciplinary. You can take a look at that. And then at the other side, right across our PhD is our healthcare flagship program. So you'll see some of the projects that we are working on. Please again interact with the people there. And finally, on near the food slide, but please talk to all these people before you get to the food, but it's okay, you can go and get the food. The purpose is we put all the food all the way at the end so that you have to walk through. So we showcase a few of our cluster of excellence. So one on social media. So we in fact quite a bit of that is more on misinformation, which is very important, especially now with ChatGPT and all this, getting very good at faking humans, right? So then of course the NLP people are looking at various techniques, federated learning and smart city groups. Okay. So with that, thank you for sitting in for so long. Again, please give us feedback. Hopefully we'll do this again. And then we'll grow together, and we have interesting program to let you know maybe next time. All right. Please, thank you again. Please go and take a look at our posters and demos. Thank you.
Right? Oh, I should have thought that out. Oh.